is we have this some material like calcite, where when you send in an electromagnetic beam, different directions will have different responses because of their inhomogeneity, the charge density, etc. So let us write down some simple Maxwell's equations again. So we start with this Maxwell's equations. Curl of E is equal to minus dou B by dou T. And curl of B is equal to mu naught J plus mu naught epsilon naught dou E by dou T. These two equations, and what is important here is that the density J, we can assume, is entirely due to the polarization current. That means you can say this is equal to dou P by dou T. And the polarization, which is the dipole moment per unit volume, is given by some chi times E. Where chi is called the susceptibility of the material. So this is P is the polarization of the medium, and now we can take the curl of this equation. So let's call this as equation 1, this as equation 2, and take the curl of 1. So curl of curl E is equal to minus curl of dou B by dou T. Now I can write this as minus dou by dou T of curl of B, because this del and dou by dou T are space and time components, and I can interchange. We are still talking in terms of space and time. So if it is space time, and if you talk about radiation, etc., this interchange cannot be done. You may be familiar with this retarded potentials, etc. So if you have a retarded potentials, then you cannot interchange these things, because T will be a function of R. Okay, so I am sure you know there are something called Jeffy-Minko generalization of Maxwell's equations, where you have to bring in this concept of retarded potentials. So I am not assuming that space-time unification as of now. This is a non-relativistic case. So and I know that this del cross B is mu naught J into this. So this is equal to minus dou by dou T of mu naught into J. I will write it here, mu naught into dou P by dou T plus mu naught epsilon naught into dou E by dou T. But I can write this immediately as P is chi times E. So I will write del cross del E as minus mu naught into chi dou square minus mu naught into chi minus dou square E by dou T square minus mu naught epsilon naught into dou square E by dou T square. And we can write down this, there is a vector identity. So we have a vector identity, curl of E is equal to gradient of divergence of E minus del square E. So I can write this one as gradient of divergence of E minus del square E is equal to minus mu naught into chi dou square E by dou T square minus mu naught epsilon naught into dou square E by dou T square. So this is the equation that an electric field will obey inside a material if it has. So the only material property here is this chi. So this chi actually determines what kind of response this material offers to this. Now let us assume that let's try to understand if we have a plane wave, that means if the electric field is equal to some E0 vector into e to the power I k dot r minus omega t. If it is a plane wave like this, then I can substitute this electric field in this, and then every del operating on this will give me a k, and every dou by dou t operating on this will give me an omega. So I can write down this one as, so this one will become minus k into k dot e, k dot, basically this is E naught, plus k square E naught is equal to mu naught omega square into chi of E naught plus mu naught omega square mu naught epsilon naught omega square into E naught. This term anyway we can cancel out, so I will have an equation of this type. Now if I assume, so this is the central equation which I have to analyze. Now if I assume, so first in simple case, let chi to be equal to 0, that means there is no material. If there is no material, this term will not be there. Then I will have k square minus mu naught epsilon naught into omega square into E naught minus k times k dot E naught is equal to 0. So this is the equation, simplest equation, if I don't have any material. What kind of solutions this equation has? If you want to understand, the first term in that is a scalar term. But the second term, we can write it in the following fashion. Assume that, suppose pick a basis such that the vector k is along z-axis. I can choose a basis to simplify the calculation. So pick a basis such that the k is along the z-axis. Then what is k? K is 0, 0, 1. Okay, or 0, 0, k, the modulus k. Then this equation will become, this equation can be written in this fashion: k square minus mu naught epsilon naught omega square into an identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1 minus k square into 0, 0, 0, 0, 0, 0, 0, 0, 1. This entire matrix, 3 by 3 matrix, operating upon E0x, E0y, E0z is equal to 0, 0, 0. This equation implies this. Is this clear? This is very crucial for us to go to chi not equal to 0. Do you understand that this equation can be written in this fashion? But if you do not understand, then what you have to do is you write component wise this equation. For example, let me write first x component. So k square minus mu naught epsilon naught omega square into E0x minus or E0x times I plus E0y times j plus E0z times k minus, what is k? K is simply 0, 0, 1, right? So that is, so let me write down, there's too many k's. So x cap, y cap, and z cap. Write it like this. This one is simply k times z cap into, what will you have here?
E naught z.
E naught z. K times E naught z. So k times E naught z is equal to 0. Now I want to write this as a vector. So if I look at first column, this is the column vector that I want. Okay. So this into E0x is equal to 0. Okay, this entire thing is 0, means it is x component is equal to 0, y component is equal to 0, and so on. What is the x component here? This into E0x, there is no x component there. This into E0y, there is no y component. Only z component, this into E0z minus k square 1 is there. So that is why only this component there is 1 in this matrix. The last term will have only one component like this. Okay, so this is the matrix equation corresponding to this one. Okay, so once we write this, then we can say that okay, this is a set of linear homogeneous equations, component electric field, and one solution of E is identically 0. And if you want to have a non-zero solution to this, then you should have the determinant of this matrix should be equal to 0. So what's the determinant? This matrix is essentially k square minus mu naught omega square 0 0 and 0 k square minus mu naught epsilon naught omega square 0 0 0. So k square minus k square. So it will be simply minus mu naught epsilon naught omega square 0x 0y 0 square is equal to 0. Now the determinant of this one is k square minus mu naught epsilon naught omega square whole square into minus mu naught epsilon naught omega square is equal to 0. So there will be 3 roots for omega square. One is 0, omega is equal to 0. Other one is k square is equal to mu naught omega naught square. So omega is equal to 0 is not very interesting because this corresponds to static electric field. Okay, there is no oscillation. And the other one is k square is equal to mu naught omega naught mu naught epsilon naught omega square. So this is interesting. If you say omega is equal to 0, if you consider omega is equal to 0, that will corresponds to E0z is equal to 0. So if you put omega is equal to 0, then if you put these two are 0 and this is any arbitrary number, that will satisfy this equation. So that is like a static. Whereas if you take this, these two will become 0. So this has to be 0, but these two can be anything arbitrary. Okay, so this is what gives rise to the solution here.